So we have our next focus activity. You notice we've already turned in the first set, which we had as numbers 1, 2, and 3. This one, we're still within the same 6 weeks, so I'm going to keep the order going. So this next set starts with number 4. So we'll most likely definitely be able to make it to number 6. Hopefully we'll get 4, 5, 6, and 7, but we probably won't be turning these in for a couple of weeks. Again, just it should be a guaranteed quiz grade. You know, you follow along with me, hang on to them, and you just turn those in. Okay, so this one allows us to go back and talk about sets again. Intersection, union, complements, all that good stuff. So let's see what it says. A squash club has 27 members. 19 have black hair, 14 have brown eyes, and 11 have both black hair and brown eyes. Place this information on a Venn diagram. Okay, so let me go ahead and draw my universe here. And this time I'll actually go ahead and put 27 there. You know, normally I don't do that, but why not? Now we know that the two groups, there is an intersection. So I'm going to draw these guys overlapping. Let's say that BL represents the black hair. BR will represent the brown eyes. Okay. Now, would anybody like to come on up and finish filling in this Venn diagram for me? A lot of hands. I just need one. Just one. Okay. Alex, would you like to come on up and do this, sir? All right. Alex, I'd like to thank you for volunteering. Okay. Does anyone else need the key for yesterday's homework? Okay. There you go, sir. And I'll take the key. Thank you very much. Boop. Okay, so we have 27 total. 19 have black hair, 14 have brown eyes, and 11 have both. So I'd probably start with the what?
Black hair.
The black hair. We could.
So,
The BL is the black hair, and the BR is the brown eyes.
so 11 in the middle.
There you go. So 11 have both.
Black hair.
Now, how do we know that?
Because 19 minus.
Okay, there we go. Because there has to be 19 people belonging to the black hair set. So that means 3 people will have brown eyes but not have black hair. Are we missing anything?
Yes.
What? Close. How many people have we accounted for so far? 19?
Oh.
We've accounted for 22 people. So there's only 5 people left in the universe who don't have brown hair or brown eyes, I should say, or black hair. So maybe they have blonde, maybe they're bald. Okay, because bald is awesome, right? Why are we laughing? Okay. All right. But here we go. We got our Venn diagram. Is everybody okay with how we set it up? Okay. Now let's take a look. B1. Hence, find the number of members with black hair or brown eyes. So this is where I'm going to take a sentence and I'm going to go ahead and rewrite it as a mathematical expression. Now, what does the or mean to you? That's not the intersection. That's the union. There we go. Or is the union. So I would write it like this. Black hair or brown eyes. Now, how many people are IB? Okay, so several people in here are IB. So I want to go ahead and show you something very quickly that may come up, especially when you're taking your paper exams. But you'd probably get the same answer anyway, but we're specifically looking for the number of members that belongs to this particular expression. So when you see something like that, you might see it in parentheses with a little n on the outside. That notation just means you want the actual number belonging to that set, like the number of items, which is what we'd be doing anyway, but I just want to go ahead and kind of throw that out there. So let's see. What would I get if I took the union of the black set and the brown set? I'd get 22, yeah. Remember, that's the marriage, the combination. So 8, 11, and 3. Now it says or, so they don't have to have both. It's okay if they just have black hair or the brown eyes, as long as it's one or the other. Okay, the union. Now try this next one, B2. Okay, try to write out what you think the expression is going to look like. Don't say it out loud. Give everybody the opportunity. Black hair, but not brown eyes. And if you're feeling ambitious, go ahead and write out what you believe the answer is. Okay, the number of people. So black hair, but not brown eyes. From the Venn diagram, you can probably tell that pretty easy. Right. Now, here's what I would write. Black hair, intersecting, but it says not brown eyes. So what does that mean in terms of sets? That's the complement. Yes, that's exactly right, Jack. So I'd say brown eyes with that little slash. Okay. So the intersection of the black hair set and the complement of the brown eye set. So how many would that be? It is just 8. The intersection of the two. Now, one thing that people have been asking in the other classes, wouldn't the complement of the brown eyes include the universe? Because it's everything outside of it, right? Does anybody want me to elaborate on this? Or is everybody okay with where we got the 8? You want me to elaborate? Okay. Imagine if I drew them separately. Okay. So I'm going to draw 2 little universes. And the circles still represent the same. I'm just not going to write it in. The left circle is still the black hair. The right circle is still the brown. So let's say, I'm just looking for all the people who have black hair. Well, that would be this whole circle right here, correct? But now the other one, I'm looking for the complement of those that have brown eyes. So what does it mean, complement? Everything what? It's not brown eyes, yes. So I'm going to shade everything in the universe outside of that set, right? Now imagine that if I could take this and I just put it directly on top of the other one. Where would they overlap? There we go. See, the overlap would only be in this region right here that kind of looks like a crescent moon. See, and that's where we're getting our 8 from. Okay. Does that make sense? Does anybody have any questions? Okay. All right, so put this somewhere safe, binder, folder, whatever. We'll get number 5 soon. We'll get number 6, and at some point we'll turn them in. That'll be another quiz grade. Excellent. Okay, let's get on to rational functions. Okay, so this is where we finished yesterday. We were graphing and analyzing rational functions, and we were talking about asymptotes, intercepts. We brought up quite a few holes, all things like that. The one thing I do want to go ahead and cover, are the 3 cases regarding whether or not you have a horizontal asymptote or a slant asymptote. Can anybody tell me one of them? And what do I look at in order to determine if it's a horizontal or slant? Okay, so Christian says the degrees. We're absolutely right. So what about the degrees? What are those 3 cases I'm referring to?
It's bigger than the numerator.
Okay, so Christian says if the numerator is larger or if the denominator is larger. So what if the degree of the numerator is larger than the denominator? Connor says that's a slant. That's when you have an oblique asymptote. Yes. What if the denominator's degree is larger? That's when you have horizontal and it's the x-axis. Okay. What if they're the same? There you go. So Connor says you divide the leading coefficients. And this is one of the things that we looked at yesterday. Okay. How do we know if there is a hole, a removable discontinuity? Yeah, if when you factor it, there's a common factor that cancels, whether it's a single term or a binomial. Typically, it's probably going to be a binomial. Okay. If nothing cancels, you have no hole. Okay. Any value of x that makes the denominator 0, those are your vertical asymptotes or your holes, depending on what happens. Where do I find the x-intercepts? Okay, the top, any value of x that makes the numerator 0. Okay, this is what we went through yesterday. So here's what I'd like you to do now. This problem is not in the packet that we had yesterday. I'm going to go ahead and throw this out there as a review because this one does something that we talked about yesterday. And I want you to see if you can figure it out. I'm going to go ahead and give you 5 minutes to get as far as you can on it. The problem is x minus 4 divided by x squared minus 3x. It's not on your paper. So I would say on the back of that packet from yesterday, or the back of that one, wherever you want to put it. Okay, go ahead and write this out quickly. And during that 5 minutes, I'm going to go ahead and pass back your papers that I have. That way, you have an additional resource to go ahead and look over for your quiz tomorrow and also for your upcoming exam. So 5 minutes. Here are all the questions we've been going over since yesterday. Okay. So even if you don't get the sketch, that's fine. Just see if you can determine all that information. Okay. What we were asking for yesterday. Let me do this. Okay, so I've got Jack. Here we go. Fawaz. Okay. Xavier. Christian. Skylar. Another Jack. Kyle. Shane. Stephanie. Miriam. Barunda. Okay, Jack Williams. Okay, Jacob. Connor. Kimberly. Ariana. Ethan. Erica. Jane. Brett. Dylan. Raphael. Satish. Aiden. Zachary. Let's see here. Bethany. Another Jack. Shayna. Jack. Skylar. And Fawaz. All right. There's all my papers. Was that one yours or was that extra? Probably an extra? Okay. Okay, is anybody stuck? Is anybody got a question? Okay. And remember, if you have a question you want to ask, let's be rational about this. Yes. Okay, now remember, this is the one case where you don't have to do anything. If the denominator's degree is larger, what's the horizontal asymptote? Anybody tell me? It's what? Y equals 0. It's going to be the x-axis. Okay. There you go. Okay, let's see how much time we got left. I got 1:50. 1:50. Now, just go ahead and let you know real fast, these other papers that you picked up, I was hoping to at least start these today, but the other classes, we've been going up right to the bell, so it doesn't look like we're going to get to do so, but I'm going to ask you to do me a favor. It's only going to take 5 minutes, and it's really going to help you out tomorrow. Please read over this. It is not going to take but 5 minutes just to sit down and take a look, and then you've got 3 examples. I'm not even asking you to do the examples. I just want you to have looked over this, because tomorrow when you come in, we're going to spend the first half, and this is really just going to be a preview. I'm not going into this in any depth, but how many people are going into calculus? Okay, so you will absolutely see this again. So if you're going into calculus, you definitely want to go ahead and take the time to look at the continuity test. Okay, so the first half of class, we'll go through some examples. We'll talk about this, and then the last half of class will be what? Quiz. There you go. Okay. Do-do-do. Do-do-do. I don't know. I never go back and watch my videos myself. So I imagine this will be the awkward part of the video where you just hear me breathing. Be kind of weird. All right, here we go. All right, so if you're not done, that's okay. You know, I just wanted to give you time to go ahead and get a head start, maybe get some of the information. Let's start by the factored form. Is there any way to factor any part of this? Yes, how? There you go. In the denominator, we have a GCF, a greatest common factor. In fact, speaking of factoring, you remember yesterday I showed you the my father method? Okay, I did go ahead and upload a document that not only walks you through that process, but anything you could ever possibly hope to factor. I created a factoring map for you. Okay, so if you're needing a refresher on factoring, anything like that, that document is there. Take a look, you know, come ask me questions. So let's see, x minus 4 over x times x minus 3. Okay, perfect. Now, will there be a whole? No, there's no factor or group factor that cancels. Since nothing cancels out, that's one less thing I've got to worry about. Okay, so the branches themselves are at least going to be continuous, as you know, what we'll talk about tomorrow. All right, so do I have a vertical asymptote or asymptotes? Okay, yes, like what are they? And how would I find them? X equals 0 and x equals 3. The values of x that make the denominator 0, they're either going to become your wholes or your vertical asymptotes. Because there's no removable discontinuity, a whole, I know this is our first one, we're going to have 2 vertical asymptotes. So we have vertical asymptote at x equals 0, x equals 3. And remember, you want to give me the equation. So this time, maybe we go ahead and graph it as we go along. So I've got this guy right here. X equals 3. Okay. Let's talk about the intercepts. Do I have any x-intercepts? Okay. Aiden, what do you think? So you're saying 4, 0? How'd you get that? Okay, any value of x that makes the numerator 0. Okay, very good. So 4 minus 4 would give me 0. So an x-intercept, I do have it 4, 0. So I'm going to go ahead and mark this right here. Perfect. Let's see. What about a y-intercept? Okay, so Stephanie, you're shaking yes. Where would I have a y-intercept? Okay, not 0, -3. Now remember, there was 2 ways we could look for it. We could either divide the constants, or we could simply replace x with what? 0. Now, if I go ahead and replace x with 0, what do you notice is going to happen? I'm going to have 4 divided by 0. Because it turned out to be undefined, this tells me there is no y-intercept. Okay, and that makes sense because what is one of the vertical asymptotes? Bless you. It is 0. Okay. Now, it's never going to be possible for a function, or graph, I should say, a branch to cross anywhere along a vertical asymptote. Is it possible to cross a horizontal or a slant? Yes. In fact, let's talk about that. What would this guy have? Horizontal or slant? Okay, horizontal. Okay, because we just talked about this a second ago. The degree of the denominator is larger than the numerator. So I know that this guy right here has the x-axis as the horizontal. But what do we already have? We have an x-intercept, and the x-axis is my horizontal asymptote. So I wanted to show you this example to say that it is very possible for it still to cross. All right. That's why yesterday, when I go ahead and draw the horizontal, I'm not going to draw it all the way through. Okay. We just have to understand that the horizontal or the slant asymptotes don't immediately exist. They begin to exist as x approaches positive or negative infinity. We call those the ends. As x gets extremely large or small, we start pushing out on both sides of the graph. Okay. Well, is there any other information? Nope. And see, this one here, we're going to have to rely on our idea of a sign chart. We're going to have to do a little bit of investigating, because yesterday we had enough information where we could reasonably go ahead and say where my branches were going to be. Here we don't. We don't have that. So let's go ahead and create a little sign chart. What are the values going on my sign chart? So I have 0, 3, and 4. Remember, what goes on the sign chart are your undefined values and your zeros. So I'm going to go ahead and put 0, 3, 4. Okay. And then 0 and 3 came out of the denominator, so they're my undefined. 4 is the 0. Now, this is one of those times where we don't have to worry about open or closed circles, because we're not solving an inequality. We're simply trying to investigate what regions are considered positive, what regions are considered negative. And what does that mean? Like, what's going to happen if I get a plus or a minus right here? So, say that again, Jack. That's exactly right. The positive or negative will tell me where that branch is with respect to the horizontal asymptote. If we get a positive, it's got to be above. If we get a negative, it has to be below. So we could go ahead, let's at least bring up this idea. We won't necessarily use all of them. You remember yesterday, though, and you probably remember from Algebra 2, when we're investigating the sides of the vertical asymptote, we just go a tenth above and below. Okay, let's just go ahead and use those. What would be a tenth below 0? Negative 0.1, right? Well, what would be a tenth above? 0.1. Okay. Well, what would be a tenth below 3? 2.9. What about a tenth above? 3.1. Okay. Now, like I said, we're probably not going to use all of those values. Okay. And you'll see why in just a second. But we've got a negative 0.1 to the left of 0. So would he still work for me to plug him into this region? Yeah, he's still in that interval, right? So let's go ahead and plug him into my factored 4. Excuse me. Well, it's a negative 0.1, so what's negative 0.1 minus 4? That would be a negative, right? Well, then we just have the value itself, so that's a negative, and then we have this other parentheses right next to it. So what's a negative 0.1 minus 3? That's still a negative. So what would this guy become? He would become negative. So everybody would agree that region is negative. So where should I put the branch? On the bottom. See, that's what the sign chart's telling me. So I know there's got to be a curve that looks something like that. Okay. And this is what we're going to have to do. If we don't have enough information, use the sign chart to figure out where your graph has to be within these intervals. Now, here's the thing. I don't have to use both 0.1 and 2.9. Can anybody tell me more than likely what type of figure is going to look like is between the two? It's going to look like a parabola. Now, I want to emphasize it's not a parabola the way we construct them, say in vertex form or anything like that, but it's going to look parabolic, okay? But here's the thing. Whatever I get for 0.1, would I get the exact same sign if I plugged in 2.9? Okay, so I heard someone say yes. Well, how do I know? Like, what's one bit of information that tells me they couldn't possibly be different?
There's no intercept.
Say it again, Christian.
There's no intercept.
There you go. If these guys could have given me different signs, I would have had some kind of intercept between them. Because there's no intercept, I know that I have to have a parabola either opening up or it's going to open down, but he's not touching the x-axis. So again, I don't have to do both of these. Dylan, what do you like? 0.1 or 2.9? Okay, 0.1. Let's plug him in. Okay, so I have a 0.1 minus 4. Would that give me a positive or a negative number? That give me a negative over. Well, we're plugging in a positive 0.1, so there's just the number itself. And then the parentheses represents the x minus 3. So 0.1 minus 3. That's a negative. So this interval should be what? Should be positive. So if I were to plug in a 2.9, what's he going to give me? He's going to give me a positive as well. So I know I'm going to have something going up here. It's got to curve down and go back up. Now, here's one of those questions that always pops up. How low does it go? See, we don't know for sure. This relative minimum right here, maybe it gets really close to the x-axis. Maybe it's higher up than I put it. Okay. Now, if you did want to know, could you plug in some values? Yeah, you can go ahead and make your graph a little more accurate. But remember, this is just a what? It's just a sketch. It's not going to be 100% perfect. Now, the information will be. Okay. Now, let's go ahead and do this. I've got 2 more regions because we have to cross at 4. So what do we know about these last 2 intervals right here? Will they have the same or different signs? They would have to have different signs because one of 2 things is going to happen. Either the branch is going to want to curve up, cross, and go like that, or it's going to curve down and go under. So depending on which one it is, if this one here between 3 and 4 turns out to be positive, this other one has to be what? Has to be negative. And we know that has to happen because there's a what here? There's an intercept. Okay, so let me go ahead and take this off. So again, we don't need to do both intervals. We only need to do one. Let's go ahead and do 3 and 4. And we've got 3.1. Let's go ahead and plug him in. Okay, so what's 3.1 minus 4? Negative over. Well, 3.1 is a positive number. And then 3.1 minus 3. That's positive. So what would this simplify to? A negative. So between 3 and 4, the graph is negative. That means it should be below the x-axis. Bless you. So should he curve down or curve up? He has to curve up. So that means bigger than 4 has to be positive. So we're probably going to end up with something that looks like this. And who knows? I mean, maybe there could even be a little bump right there, a little hill. Maybe, for all we know, it goes above and then comes back down. See, if we wanted to know for sure, we'd go ahead and plug in some values. Okay. But I'd say with what we have, no technology, we have a really good idea of what the rational function should look like. Okay, is everybody okay with how I did that? Did anybody get the entire graph? Christian, okay, so a few folks, good. Now, let's see how close we got. Okay. Label my points. There we go. You're absolutely right. I'm not even looking. Was that Jack? That was Jack. Okay, didn't even need to look. I got it. All right, so let me go ahead and plug this in. X minus 4 over, what was it, x squared minus 3x? Okay. So how'd we do? I'd say we did a pretty good job of figuring out what the graph looks like. Now, this is what you're going to be expected to do next week. We'll probably have a quiz over this next week as well, but you won't have a calculator, so you definitely want to practice this. And when are you getting the practice? Friday. Yes, ma'am.
So this isn't going to be
This is not the quiz. The quiz is rational inequalities. So you will be creating a sign chart, closed, open circles, the whole thing. Okay. Yes.
So we don't have to get the exact points. We just have to make it look like the actual graph.
Oh, yeah. I mean, if you wanted to, you can go ahead and plug in, like, for example, if you wanted to get a relatively good idea of where the relative minimum was here, I'd probably plug in maybe a 2, something in this interval, and then go ahead and simplify it. But I think we're good enough.
All right.
I think it's just fine. Now, if you want to make your graph more accurate, go for it. Okay. Would you want to do that?
No, good.
No? You're good? Okay, Connor's good. All right. Now, I do want to go ahead and show you one more thing before we move on to our last topic today. Let me go ahead and take this off. So, were there any questions on this? Everybody's good? Okay. I want you to consider this function. X squared minus 9 divided by 2x squared plus 1. Now, we are not going through the entire process. There's just one thing I want you to find about this function. What are his vertical asymptotes? Okay, so take about a minute or so. All I want you to do is determine where his vertical asymptotes are, because there's another point that I want to drive home. And as we've just seen, is it possible for a graph to look like he's going to cross a horizontal asymptote? Yes. Yes, that's exactly right. Okay, we just saw it. So that's why, we don't want to draw the entire thing. Okay. Okay, so x squared minus 9 over 2x squared plus 1. Now remember, I'm not going to give you as much time on this one. I just want you to find the vertical asymptotes. Now, let's at least start with the factored version. How do I factor x squared minus 9? X plus 3, x minus 3. You get conjugates because it's a difference of squares. So x plus 3, x minus 3. How do I factor 2x squared plus 1? Okay, you can't. I mean, you could force a GCF out of it like a 2, but that's not going to help you do anything. So we're not going to say it's factorable. So 2x squared plus 1, but I would still want to find the information. Okay, so by show of hands, how many people believe they have the answer? Or let me step back. How many people have the answer, but they are not 100% confident that they are correct? Ooh, I was hoping to get a few more hands up. Rhett, you were the only one raising your hand, so what do you say, sir? Oh, no, sir. No. Okay. Christian? 1/2? No. Anybody else? Okay, I've heard 1/4. I've heard a 1/2. Fawaz, you think you got it? No. Now what? Now you're getting it. Christian says imaginary, so let's see what happens there. How many people had imaginary? Aiden, did you have it? Fawaz, did you have it? Okay, so the fact that it went out imaginary is actually really important. So I still need to know the values of x that make this 0, right? So I'm going to set him equal to 0. 2x squared plus 1 equals 0. But the second you start to solve it, this is where hopefully a big red flag is going off in your head. Because eventually, what am I going to have to do? I'm going to have to take the square root. For what? Yes. So that would be x squared equals negative 1/2. I take the square root. So I'm not going to worry about rationalizing it because we don't like the radicand to be a ratio. I'm just going to go ahead and say I square root of 1/2. Okay, but here's the thing. We're looking for all the real values of x that make it 0. The fact that it went imaginary tells me that there are no real values that'll make this 0. So what does that mean for my vertical asymptotes? Stephanie? There are no vertical asymptotes here. That is very possible as well. So there are no vertical asymptotes. But I still have x-intercepts? What would those be? No, those wouldn't be imaginary. What values of x will make the numerator 0? Positive and negative 3, so those are my roots, right? What would be the horizontal asymptote? And I'll go ahead and say horizontal because the degrees are the same. What do we do if the degrees are the same? We divide the leading coefficient. So my horizontal asymptote would be y equals 1/2. So I want you to take a look at this graph for just a second. Okay, let me come on back over here. Control divide. We had x squared minus 9 over 2x squared plus 1. Now, you don't see the entire thing, but this guy would dip down, come right back up, and go in the other direction. Okay. And you'll notice everything you said is still correct. There are no vertical asymptotes here. There were no holes. We didn't have anything cancel. It is crossing at 3 and negative 3. And you'll notice if I do go ahead and draw a line here at 1/2. But again, what did I do? Okay, I didn't draw the horizontal asymptote all the way through. Okay, because remember, he doesn't exist yet. He only exists as we start to push out along the x-axis in both directions. How are we doing when it comes to rational functions? Are we feeling better? Okay. Well, all right. Document B. Last idea. All right. We want to talk about those oblique asymptotes. What does that mean? Slant asymptotes. Okay. So, let's see here. It says the graph of the function h equals x squared minus 7x plus 2 divided by negative 2x plus 6 is pictured to the right. Find the equation or equations of the asymptotes of the graph of h and draw them on the graph. Okay. So just by looking at the picture, the way the branches are, I mean, you can tell we're going to have some kind of slant asymptote here. Would you say it has a positive or a negative slope? I'd probably lean towards negative, okay, because of the way the branches look. Okay. So there's two ways to do this. You can either use long division or you can use synthetic division. So only first period was I able to actually show both of them. We had time. I don't know if we'll have time today. Let's go ahead and choose one. Okay, second period shows synthetic division. Okay, so by show of hands, as long as you're able to do one of them, the method does not matter. I just need you to be able to divide and figure out what the slant asymptote is. How many people prefer long division? Okay, there are one hand going up. Okay, 2. How many people want the synthetic? Okay, so we'll go ahead and talk about the synthetic, but those folks who raised your hand for long division, I would encourage you, try it using long division. What should happen? You're going to get the same answer, or at least you should be. In fact, let me do this because a lot of people in the earlier classes did not remember the terminology. Negative 2x plus 6 divided into x squared minus 7x plus 2. What do we call negative 2x plus 6? Hayden? This goes way back to your elementary days when you were first taught this. That's your divisor. Okay, what you're dividing into is your dividend. The answer we're looking for is your quotient. Very good. Very good. I just needed a little bit of help, for the other classes, but that's excellent, excellent, excellent. Now, let's go ahead and take a look at synthetic division. Okay. Now, if you're dividing by a binomial, one of our conditions, if you'll remember, or maybe if you're not, that's okay, we want this to be a 1x. So whatever we have here, we're going to go ahead and divide through. So negative 2, negative 2. This is going to give me 1x minus 3. See, and I'm setting up my long division. I've got my little half box, and I've got my line right there. Now, here's the only trick. If you need to divide your divisor in order to get the coefficient 1, you have to divide your dividend by the same thing. So I would have to divide all 3 by negative 2 as well. So 1 divided by negative 2, that would be a negative 1/2 x squared plus 7/2 x, and then minus 1. 7 divided by negative 2, or excuse me, negative 7 over negative 2, and then negative 2, or positive 2 divided by negative 2. Can't talk today. Okay. All right, so what's going in the box? 3. It's the value that makes that denominator 0, that divisor. And even if we hadn't divided it, if you plug 3 into the original, that's still going to make it 0. So see, it's still matching up. Okay. Now, the coefficients and your constant of your dividend, you put them in standard form. That means we want to start with the largest power. We write them in decreasing order. What happens, though, what if this one had just gone from x squared to -1? What if it's missing a term? Yeah, you got to replace it with what? 0. You have to have a placeholder so your like terms match up. So I'm going to put these to the right. So -1/2, 7/2, -1. Okay. Now we get out of here at 52, right? Yeah, I didn't think we are going to have long division. But if anybody wants me to, just remind me and we'll go ahead and run through it. Okay, it's not a big deal. It's whatever you want to do. So how does synthetic work? How do I start this process? Miriam? So you are going to multiply, yes. In fact, you're going to alternate all the way across. You're going to multiply, add until your entire table's filled in. The first value outside that box always drops below the line. If you're above the line, you're going to add. If you're below, you're going to multiply. So now, just like Miriam said, what's 3 times a -1/2? -3/2, right? So I'm going to put that right below the next value, beneath them in the column. And now that I'm above, I add. So what's 7/2 plus a -3/2? 2, because 4/2 is 2, right? And now I start the process all over again. What's 2 times 3? 6. Put that in the next column. Plus -1, 5. So what would 5 be? My remainder. There we go. And normally when you write these out, you put the remainder over the divisor, but we're looking to find a slant asymptote. So I'm not going to be interested in the remainder. All I want is the mx plus b form. And that's what we have here. Now remember, your answer is always going to start 1 degree less than what your dividend began with. Our dividend started x squared. So my quotient will start x. And then after that, you just have your constant. So if you go ahead and put them all together, I should have a slant asymptote at y equals -1/2x plus 2. Okay, so let's see if this fits with the graph that I have. If I go ahead and put a plus 2 right here, and then I got a slope of a -1/2, down 1 over 2, down 1 over 2, down 1 over 2. Now for this one, I'll just go ahead and draw the whole thing through, okay, just so you can see it. But does it look like it fits it pretty well? It looks to me like, again, those branches are always going to try to hug those asymptotes. Okay, they're going to get really close. Where's my vertical? It is at 3. Remember, we're still looking for the value that makes the denominator 0. And that's why we put this 3 right here in the box. So if I were to put a vertical asymptote right here at 3, again, does he fit? Yeah, he seems to fit with that graph really well. Okay, do you guys remember this? Okay, is the synthetic kind of coming back to you? Okay. Now, there is another one here that we're not going to be able to get to, but it is already worked out on the notes. I would probably encourage you try long division, try synthetic division, but see if you can get that slant asymptote. Because will you be expected to do that for the test? Yes, that is a big yes. Okay. Now remember, you don't have any actual written homework tonight, but I would like you to do what? Just take this. It will not even take 5 minutes. I'll be surprised if it does. Just read through this in preparation for tomorrow. Especially if you're going to be joining calculus next year, you're going to want to look at this. Okay? All right. I think that's it.